This video covers the second exploration of identification of unknown metal by reaction with hydrochloric acid. Your professor will provide you with the information that you need to record on page 117. You will be provided with an unknown metal assigned as B in this video, along with two other vials of the same metal sample, but those two vials are labeled and pre-weighed. For this exploration, you will determine which acid concentration will be the best to use for your assigned unknown metal.
It's a 105. The basic idea is the reaction should not be too fast. If it's too fast, we don't even have the chance to collect our hydrogen gas. But if it's too slow, we're going to stay here until midnight. That's no good either, all right? So simply take your test tube, go to the hood, add about a ½ inch of our, that's it, all right? About a ½ inch of each concentration, all right? So one is 1, the other is a 5. Beautiful, that's it. All right. Now you're going to place one piece of B metal, depends yours, and one piece of both should be on one together. All right. So now you're going to place both at the same time and then jump. Now you can see 1 molar gently react bubbles, and then but the 5 it's almost gone. Almost gone. Too fast, all right? So for us, this 1 molar looks very nice, all right? Very nice. Once when we decide this, very nice. You see, we have plenty of time to do our own work, and then this one's long gone. No good.
Once we have decided on the HCl solution to be used with our metal, we will proceed to set up the apparatus to conduct trial 1 of our experiment.
All right, add 10 milliliter our chosen HCl, right? Make sure. Beautiful. That's it. Add HCl into the Erlenmeyer flask, which is our hydrogen generator today. All right, very good. And then just leave on the side. First thing first, bend your conductor tubing hooked with a pinch clamp. All right, that's all you need to do. And then the other end, stick into your collector, which is a plastic graduate cylinder. And now add water overflow. All right, I will tell you what I meant by that. In other words, water should be overflow. I know for that. Why is not opening? Right, take the wax paper off from the pure film. Because the wax paper is no use once it's done. Okay, that's all. Okay, very well. And add about 300 milliliter water into the big beaker in front of us. And then have our, oops, excuse me. Hold like so. Now, watch what will happen, all right? So, say, I will let you see, all right? 1, 2, 3. Okay? Now, you can see, no matter how skilled you are, and you will have some air trap inside, all right? As long as it's less than 5 milliliter, we're okay. Otherwise, we need to redo it, all right? Otherwise, we need to redo it. Now, I will act like two of you. However, this part actually it's two people's job, all right? One person dump one of the samples inside into the Erlenmeyer flask, all right? Now, you have two, so now you need to say, for example, I have a B149 and then B150, all right? They're in the sequence, but it doesn't matter whether they're in sequence or they're not, as long as you juggle down the weight, all right? You remember which one it's your trial 1, which one is your trial 2. So now, if you cannot read, but still there is some air bubble inside, say 1 milliliter. And then you simply tap once, tap twice, tap 3 times. For ready, and then you need to dump the entirety into the Erlenmeyer flask, like what I do now. Dump all in, cover it, and then release. And then you can see the hydrogen gas is being generated now, and then go through this tubing, and then come up and then pushed water layer down from our graduate cylinder. And then now only thing you need to do is close our sample valve. Do not have any water or acid get into it. And then simply keep shaking, keep reacting our metal pieces with HCl, hydrochloric acid, until we don't see any metal pieces anymore, okay? Very well. In other words, we're going to assume once when the metal is disappeared and then the reaction stopped. That's all right? you can see the reaction is no longer as fast as the initial one. Push it, HCl was being generated in a large volume, but now just a small little. But it's still, we still see few pieces, small pieces, right? Still reacting, still reacting. So it just takes a little more time. You can see still one piece and two small teeny tiny pieces. Okay, so almost done, almost done. All right. There's still small little tiny one. Yeah, still, all right. So we're going to keep shaking. Now it's all gone. No more metal pieces anymore, all right? And then before we can do anything, remember, we're going to block everything in between. So now the pressure inside of a graduate cylinder, it's equals outside. Now we can take our action off from the Erlenmeyer flask. All right, now you are asked to take a reading how many milliliter of hydrogen gas you have collected. Now before you can do it, look, we have this much of test tubing and the glass head on top of water. Those occupy volume, so we needed to take it down, all right? Be very careful when you try to move it down below the